Good afternoon, everybody. And I told takes a while. So actually, this is a spillover from yesterday. So definitely, I'll talk a little bit about hybridization, but more about everything in general, especially putting into perspective what we saw yesterday and the new insights which JACKAL researchers gave out. So I had a chance to actually learn about this after that. A little bit about the perspective of India. So we have about 24% of our geographic area which is under forest cover. A lot of protected areas. But the problem is that there are a lot of people, 1.4 billion people, and the size of these protected areas is small on the average. You have some big ones also, but the largest being up close to about 50,000 square kilometers. But on the average, they are quite small. The economic growth of India, as you know, is quite good, and there is a huge pressure from the government to maintain this rapid growth in economy. And that's a major concern because, as Mahatma Gandhi said, there's enough for people's need, but not for people's greed. And if we go with this rate of growth, it is going to definitely have environmental impacts. That having been said, India is home to over 75% of the world's tigers. We are close to about 3,000 tigers, 65% of the world's Asiatic elephants, and a lot of leopards, a lot of large carnivores, living with people. So that's a sort of a contradiction of sorts. And how this contradiction exists gives us a lot of insight on what the rest of the world can actually do for today's Anthropocene level of conservation. And that, I believe, essentially is how human attitudes are towards biodiversity. And that's shaped a lot by our culture and religion. And without any offense to any religions, the Western religions, the Abrahamic religions, talk about dominion of nature, while the Eastern religions of Hinduism, Buddhism, Jainism talk about custodianship of nature. So this is the basic difference between how people view wildlife, conservation, biodiversity. And just, it's not the magnitude of people which make all the difference, because you have 1.3 billion people. Still, you have almost an intact large carnivore community without exception of the cheetah. Everything else was intact. And most of our ungulates are also in place. So that, we talk about Yellowstone National Park as being the first national park established in the world, but we had national parks in India at 400 BC, before the time of Buddha. So, national parks and the culture of using legislation to govern natural resource management was first written by this gentleman here in his treatise known as Arthashastra, of laws related to all aspects of life, including regulation of forest use, produce and all that. That was around the 4th century BC. Okay. So all this was there inculcated. The golden jackal, which we talk about, features in the Buddhist Jataka tales, okay, and Hitopadhyaya, which are ancient texts just after Buddha, so somewhere around 3rd century, 4th century BC, and in the Jataka tales, which are also very important. They're sort of personification of Buddha's lives as animals. He was reincarnated as animals, and then he interacted with all forms of life. And jackal was a very important element in there, where the jackal was considered to be extremely wise individual and intelligent individual, and solved a lot of problems for other creatures on the planet. Okay, so that is the background of jackal mythology in Indian culture. Okay, so the government of India, in modern era of conservation, we had huge problems with tiger numbers. And tigers were estimated from their paw marks, okay? And that led to a lot of inflated numbers. And then there were crashes in tiger populations, and in 2005, the government of India approached me and my team to develop a national strategy for estimating tiger status based on modern conservation science. So I took this opportunity, because there was money for tigers, and used it to develop biodiversity monitoring plans for the entire country, where we monitor mammals and habitat, ungulates, carnivores, and anthropogenic pressures across the entire country, divided into 100 square kilometer grids. the same as the size which Jennifer showed today about Europe. And this results in a huge amount of effort. And we got the Guinness Book of World Record as the world's largest wildlife survey ever conducted in 2018. And the last survey we did was even larger than that. Okay? So you can see we have about 44,000 people walking the forest in an occupancy-based analysis to collect information. And then if you look at the camera traps over here, 32,500 camera traps deployed. We had about 447 million wildlife images, which needs to be put to species levels, jackal being one of them. Yeah? And lots of, the whole idea is to estimate tiger populations. So we had about 97,000 tiger images, and from which we identified about 3,000 odd tigers. Okay? So using computer-based artificial intelligence and so on and so forth. So this, we developed a program known as M-Stripes, which is a mobile application which allows you to do smart patrolling as well as collect ecological information at landscape scales, geotagged, geo-referenced, with photographs so that nobody can fudge data. Because we use a lot of the wildlife department staff to collect information for us. And so this mobile application is then used across by all those 44,000 people who are actually taking a mobile in their pocket and having this data filled in. So there's no errors when you transfer data from data sheets to the computer, because GPS locations get written incorrectly. So what the guards do while patrolling is that they have the track log with the mobile phones, and every time they encounter an incident, it is photographed and geotagged. Okay, so this is all then transmitted through the internet onto the main server at my institute, the Wildlife Institute of India, and then we analyze this country scale data. Okay. So this becomes easy to deal with when you're looking at about 300,000 square kilometers of area and information coming in. So we had about 470 million photographs of wildlife. Imagine going through them and sorting them out. So we use an artificial intelligence-based program, AI-based program, which allows for species segregation. Again, developed in-house for India. And you can segregate, of course, there are errors, there's not 100%. But marked individuals like tigers, leopards, spotted deer, clouded leopard, almost 90 to 100% accuracy in their classification. Deer sometimes get messed up because there is very little information set. So this is just the general stuff of how this information was collected and what we can do with it. So we have 3 canids in the country. Of course, the golden jackal, the Indian wolf, and the Himalayan wolf. So these two, which Geraldine will talk about, I'm going to talk about the wolf now. So anyway, I won't talk about the wolves anymore, but I'll talk about the golden jackal. And of course, these, if you look at the body measurements, there are 3 distinct, morphologically 3 distinct species there. And if you look at the molecular level, you can see the dogs, the golden jackals, wolves, and this based on panel of 25 microsatellites, they all separate out very well in discriminant space here. So this was the national surveys, and I also had specific research projects on many species, including jackals. And this I did somewhere in the early 90s. Okay, so we called a lot of jackals in those days and monitored their ecology, home range, foraging, paths, and breeding behavior, and so forth. So this is providing all information. The distribution of jackals in India is across India, except very high altitude, about 3,000 meters. The last record I think we're publishing in one of my students has written up for Ladakh. And the highest record of jackals is 3,000 meters in Ladakh. And they're not found in the mangrove forests of the Sundarbans, but everywhere else, and the extreme desert, everywhere else you get golden jackal. So we used information from these camera traps as well as secondary information on SCAT as well as radio telemetry locations, and modeled them in Maxent to look at species distribution models. Okay. So we have close to about area recorded by jackals, covered by jackal today, and considering a conservative estimate of at least a pair in every 50 square kilometers of both inside jackal, about 30 square kilometers. Yeah. We have at least more than 100,000 individuals, so it's not a big deal. But the threats to jackals include diseases from dogs especially, roadkills, dogs themselves as competitors, and then persecution by people. And recently, the Wildlife Protection Act was amended, and the jackal was offered the highest level of protection under it. So if you kill a jackal, you can be in prison for 3 years.
Wow.
Yeah. So, yeah, and a fine on that as well. So there's no hunting in India. Nobody can hunt anything for that matter. We declare some species as vermin when they become too many. For example, the nilgai and the wild pig. And the farmer can shoot that with permissions from the government on his land, but you can't eat it. Okay? So you have to give the carcass to the government and it's incinerated or burned. So very few people actually resort to killing anything, and that's how the law is. The roadkills are a major issue with jackals. As soon as we develop in India at a very rapid scale, major highways, 4-lane, 5-lane highways are coming up. And as soon as the highway comes into the picture, you have initially a lot of roadkills of jackals, and after a couple of years, 3 or 4 years, nothing. Okay? So the whole population is gone. And that's a major concern because the roads are coming up. So I use this information on photo captures to time the activity budget. Yeah? And what you see is that this is from 26,800 camera trap records, 21,000 records from that many cameras. And you see that it's a huge number. I'm trying to show off here. You don't have to laugh at it. So you have a crepuscular activity at 6 and in the evening. Yeah? And they're more nocturnal than diurnal. Okay, so this is an interesting clip for looking at interactions. So this is a leopard and a jackal here. Wolves, not a friendly one. Hyenas are arch enemies of jackals. Dogs. So almost the whole spectrum of what we saw yesterday happens back home, where jackals have been there for a much longer time. Yeah? So this gives us a lot of opportunity for interactions between these species. And there is a whole theory and hypothesis of mesocarnivore release, in the sense that when a top carnivore is present, it takes care of the tertiary carnivore, and then all the smaller carnivores actually flourish when the top carnivore exists. So you have the leopard, which is the the secondary carnivore, the second level carnivore in India, and the top carnivore is here. And of course, the leopard is controlled a lot by tigers. Wherever you have high density of tigers, leopard populations are much lower. And if the leopard does not have any escape cover, then the leopard is finished. So you don't have leopards in Sundarban, mangrove forest, because the leopards can't escape anywhere from tigers. And the tigers get rid of them. But tigers also do this. This is not expected. They should be caring about jackals, but yes, they go and kill them. So high density of tigers are detrimental for many, many other species, including jackals and jungle cats and caracal and whatnot. Yeah. So and with our a sort of a one-track mind of increasing tiger numbers in our country, we manage for tiger population, not for the others. So we try to enhance the tiger populations by making the habitats more productive for ungulates, and thereby increasing their densities at the cost of many other species. And this has been a difficult task to convince the wildlife managers that, okay, don't inflate tiger numbers beyond what the natural carrying capacity is. Okay, so this gives us a lot of scope of interactions. Yeah? And you see this jackal, this is likely hybrid. You have probably a dog or a hybrid, mixing up. Black colored jackal, melanistic jackal, this is a wolf consorting a dog. Wolf-dog hybrid, actually known to be a hybrid, tested with molecular stuff. This also is a hybrid, wolf and a dog. And this one is the alpha male, which sired these cubs, so they're probably all hybrids. And you have mating events in the Himalayan wolf mating. Okay, so with a dog. So these interactions are quite common. but molecular evidences for them were lacking in recent times. So one of my colleagues, Uma Ramakrishnan from NCBS, has actually done SNP-based, SNP-based, and she's just published a paper, and our paper is also published very recently. You may not have seen it, but so we used a panel of 25 microsatellites and could easily distinguish hybrids, putative hybrids, from wolves and dogs. Okay? But we looked at wolves and jackals, but we didn't find any. So we had one putative hybrid, but it fell squarely in the jackal cluster and not in the dog cluster. So it just might be some morphological aberration in the jackal, but we don't know till we do some full genome or genome lens SNP-based analysis of that. This is a paper which I had shown last time, and we published in 2015, looking at the mitochondrial control region and cytochrome B distribution of haplotypes across India. At that time, European haplotypes known were very few, and there was only one which was known there, and we had the Middle East and India having the richest form of variation in the mitochondrial genome. And this is the neighbor joining network here. Control, and this is the control, sorry, CIP, and that's the control region. And you can see here that this is all Indian, and this is from Israel, and that's from Europe. And over here, this is all Indian, and this part here, Israel and Bulgaria. The rest is all haplotypes are from India. So we had shown that India has very rich diversity of jackals at the mitochondrial level. We've done further added samples to it, and you can see that now again much more variation this is just Indian samples, and you can see there is more haplotypes that we discovered, about 26 new haplotypes in this region. And if you look at the global distribution of from the control region, this is India, all the haplotypes from India, haplotypes from Europe and the Middle East. Very distinct material lineages. Okay? Now, and Thailand stands apart. So we don't have samples from Cambodia, Thailand, and those areas. We need more sampling of jackals from those regions. I have been collaborating with Laszlo as well as Raquel from Portugal, and I think we got some very nice publications coming in the near future. They are all in review for global this thing, but I couldn't refrain from putting in one figure which I'll show you. So this is the genetic structure of golden jackal within India, okay? And using structure from microsatellites and at different population levels. This is about 136 individuals where each bar represents one single individual. And what you see is there is a lot of mixture. There is hardly any pattern as such which you can decipher from here, except in South India. So these jackals are from southern part of India, which was connected with Sri Lanka in about 11,000 years ago with a land bridge. So we expect that, and it's classified as a separate subspecies of the jackal. Right? The northern part of India has a different subspecies, the southern part of India is the same subspecies as Sri Lanka, but we didn't have any genetic evidence to actually suggest that. So this talks about the same thing, but in a more comprehensive, more analysis. This is mitochondrial analysis based on the haplotypes there, and it says there are 5 populations, but again you see that there is a matriarchal lineage in looking at the South Indian population and the Northeast population, which is similar. So if the jackals came into India from Southeast Asia, you would see something like this. So until we have Southeastern Asian population samples, it's going to be very difficult for us to pinpoint whether jackals actually originated from India or came into India from the Indo-Malayan belt. So that's when here in the DAPC you can see South India standing out, the rest of them form in a single cluster. Okay, so this is a unpublished, none of this is published yet. This is from Raquel's paper, you've seen this. So if you look at the genetic diversity, heterozygosity, you see that maximum is from India, and as you go further up, shows that as the colonization happened in form of beings, loss of genetic diversity on the edges of the colonization. For demographic patterns, this is a little different than Wesler, what you have shown through your SNPs, but I presume yours is far more robust than what we have done here. You see that there is an increase in the jackal population at about 1,000 years ago, 1,000 generations ago, which would be about 4,000 years ago. That's when pastoralism started in India. The Aryans came in with a lot of cattle, and you had a lot of food in form of livestock available, droughts, so there was more grassland habitat. The jackal population increased and it started to crash in the last 300 years. Okay, so this is generation time. So that's when human impacts, I would say, have taken over, and then the populations have crashed because of development, mega civilizations, and so forth. This tells us the gene flow between different subpopulations in India. Okay, so from South India, you can see, where's South India? Right here. So you can see gene flow into Tarai, into the northeast, into North India, so forth. So there's all very good mixing of genetic material from across India. So there's no isolated population, so you don't have to worry about genetic diversity. And this figure tells us at which level genetic relatedness becomes zero. Okay? So at about 500 kilometers, when you look at sampling intervals, animals within 500 kilometers are related, but as soon as you go beyond 500 kilometers, there is no relationship with genetic diversity, genetic relatedness and geographic distance. Okay. So this is about now home ranges. They are normally about 25 to 30 square kilometers. Core areas are exclusive, but ranges overlap a lot. And jackals have a tendency to forget about territoriality totally when there is aggregation of food, like what you see here. Yeah. And in this case, the study place is where I did my PhD work. We had synchronous calving of blackbuck calves. Okay? So they drop their calves within 2 to 3 weeks, and there's a huge herd there. So at that point in time, jackals from 40-50 kilometers away would make a beeline to this national park where the blackbuck would calve. Okay? And then there's no territoriality, and all these animals just aggregate and feed on calves as much as they can, and then the calving season gone, they go back where they came from. So that's an interesting, which wolves don't do. Wolves are also here, but I'll talk about that a little more. But wolves are territorial, and it doesn't break up. Even though there's a surplus of food for certain times, they won't allow other wolves in. The villages form a very important source for jackals, and this is looking at the foraging paths through the night, following a radio collar jackal and tracking its path, and then looking at the landscape level resources available and whether they're following those resources while they're foraging, or is it just a random walk. And we saw that they were following tracking resources when they are foraging. And village dumps are one of the most important food sources for them, and they would visit them on a regular basis. Okay, so this is a long-term research which I did with wolves, blackbuck, and now jackals and hyenas, which have come into the picture. And this started off with my PhD work. And this herd blackbuck is, this is what was happening from 1969 till 1917 when I stopped working there. What you see that the population was stable at about 2,200 individuals with fluctuations happening. It's on a log scale. Okay? So fluctuations happening when there were droughts. So whenever there's a drought, population would crash, again it would build up. Then in the early 80s, this area was colonized by wolves. There were no wolves, no predators earlier. So the carrying capacity from nutritional level was now regulated by predators, and that's what at least I thought when I started studying this system. And I thought the wolves have come in, and now they're regulating them at about 1,200 blackbuck in that herd. Okay? And subsequently now, again the population has gone back to about 2,200. Okay? So interesting, why? And the reason what I found with my research was that the wolf predation was selective on males. Of course, that's why you have a skewed sex ratio. Males are very few compared to females. Because the blackbuck has a lacking system. Okay? So the males aggregate in an arena and display to the females. The females come and choose the male whom they want to breed with. And at that point in time, they're very vulnerable to wolf predation. So the wolves would just come and pick up what they want, and the black buck was thrown caution to the wind. So there was a very high mortality of males on the left. And that allowed the, so that allowed the shaping of the population structure. Now this is a mortality curve of black buck. What you would expect normally it to be a U shape, that young animals die and then very old animals die. But at the best of prime of life, you have the highest, lowest mortality, highest survival. But in this case, black buck mortality goes up when they are about, they start breeding at about 5 years of age, they start flecking, and it's maximum at the 8 years of age. But if you survive beyond 8 years of age, you can't hold a lek territory anymore, and you're not vulnerable to predation. So your survivorship goes up. Okay? So old males survive better than young males. Okay, so it's a sort of contradiction, and that's because of wolf predation. Okay, so the black buck, the most critical phase in their life is during the calving stage, because there's a lying out phase of the calves, and the female just leaves them and then comes back in the morning and evening to suckle them. Otherwise, they are left alone; they're odorless. But if there's no cover, there's a drought here or something, that it's like this. So they lie down to the ground, but they can be easily picked up by wolves, by jackals, whatever else. And it is at this time that all the jackals start aggregating when the calves are dropped from all over the place. So I didn't realize, jackals are insignificant creatures in India. So who bothered about jackals? But then I realized that it was wolves were just, there was just a pack, and they just couldn't control the black buck population. So there was something else going on, and I started looking at jackals. And what I found is I put transmitters on them, and they moved from 40 kilometers away to this area, and they could achieve a density of about 1 to 2 jackals per square kilometer during the calving peaks, just like what you have here. And so I simulated the dynamics of it, looking at survivorship, because I had good data on black buck life tables and all that. And what I found that the only model which actually shows a stability in the population was that with jackal predation on calves. And that's what was manifesting, just not the wolf predation, but the jackal predation along with wolf predation. So coming back to this phenomenon, the 2000 is, now we had wolves coming in the 80s, the hyena came in the 90s. Okay? So this system was extremely dynamic. We didn't have hyenas in that area now. Once the hyenas came in, they controlled the jackals. So the jackal density from 1 to 2 per square kilometer dropped to about almost extinction. About, yeah. And the black buck population jumped up again to nutritional carrying capacity. So actually I know nutritional carrying capacity because I've done nutritional work on the black buck and looked at productivity and so forth. So that is what, about 2000 is what was happening. So this is a classic case where predators actually regulated the prey population through predation. There's one other case in India where predation on ungulates actually resulted in their almost becoming extinct. And this is the case of the swamp deer, a hard ground barasinga. We've got 12 tines, so they call it barasinga. Bara means 12. 12 tines in their antlers. And that was due to tiger predation in Canis National Park. So, but now the jackals are playing that role, so I'll come back to that. So this is the swamp deer. Now, in this area of Kana meadows, we had high level of tourism. So before the 70s, tourism, tiger tourism involved baiting. So they would tie a buffalo, and the tigers would come in to kill the buffalo. Of course, you know how big the buffaloes are. So there's a lot of food, and the tigers would aggregate there from all their territories would merge in the area of these meadows. So very high tiger density. And also there is a alternate prey, the cheetal deer, besides the swamp deer in this area, very high densities. So the meadows of Kana, where these barasinga or these swamp deer live, had artificially inflated tiger densities. And they preferentially kill barasinga because these guys are quite naive. They are the only deer who actually go and mob the tiger. Okay. So all that so they like to keep the tiger inside, and you'll see them calling, and the tigers see, and they'll start following the tiger. The tiger just needs to sit down and hide in ambush till the deer approaches, and it's very easy to kill them. So there's preferential predation on barasinga. So we didn't know that, but subsequently what we decided was that we'll put them in a predator-proof enclosure. There were only 66 left, entire global population of this subspecies. Put them in a enclosure, predator-proof enclosure. So this is the population growth outside the enclosure, and this is the predator-proof enclosure. You can see as soon as predation was controlled, the population started growing. And today we have close to about 800, and we have established several populations from the Kana population. So we have about 3 different populations already there. So this was taken care of. But now, in the meadows of Kana, jackal density has gone up tremendously. Okay? And those pictures are from Kana, the tigers killing the jackals. So we don't know yet, but I think they are playing a very major role in controlling fawn predation and recruitment in the Barasinga population. But we need to study that further, of how. Because you see jackals just walking around with the herds, the deer give up caution, then all of a sudden a jackal will lunge and eviscerate. Serve it, even adult serve it, no issue. Small little thing, but you can kill an adult cheetal or even a Barasinga. Fawns are very easy. So they are very clever, vicious predators. Okay, so this is my last slide. This is a very important conservation initiative because we have a lot of people and very little space for wildlife. The laws of India do not permit eviction of people from forests. Okay? You cannot evict anybody. You can evict people if you're making a dam, you're making a factory, expanding a road. Any development and activity, you can acquire the property of that person by giving compensation. Okay? There is no right to property in India, so the government can do that. But the law does not permit eviction for conservation. So what we did was we formed another law, the Wildlife Protection Act. We amended it, and we built in an incentive, so that people would take that incentive and move out. So it's incentivized voluntary relocation. You give them so much that they can't refuse. Right? So within the core areas of parks, you have these small hamlets, and these people suffer a lot because there's predation from tigers, elephants eating their crops, children don't have school, no medical facilities, no electricity. You give them a better option of about $20,000 US for adults in the family. It's a lot of money for a poor Indian. So every member of the family gets that amount if you're over 18. And they move out. And you get better housing, facilities, hospitals, electricity, schools. You join the mainstream society. So there's a lot of people waiting to get this benefits and move out of protected areas. And that's a very important scheme. I think the only scheme across the world which I've come across where the government actually pays for people to move. And invests close to about 12 million euros each year in this activity. Okay, so this is the funding support which is solely from the government, which comes in. This is the only central government component. We have the state governments also putting in a lot of money in this, especially with the land and this thing. So what it results in is that you have intact biodiversity areas and people are happy. The vote bank is happy, they give vote to the government, the politicians are happy, and it's a happy ending for everybody. Unfortunately, the government has stopped funding for this scheme in the last 2 years after COVID, so we're trying to revive that, but hopefully that will happen. Okay, so thank you very much. These are some of my acknowledgements. I'd like to thank the organizers of the symposium and for the workshop who have invited me and given me this opportunity to talk to you. Thank you so much.